We have seen that motion is relative. So I hope you guys remember this video. So we have a bus which is not moving, looks to be so. And we have a dot which is not moving. But if I happen to change the perspective, I can make you guys feel that it's moving. That's the entire movie industry. So it's just a bunch of pictures which makes you feel something is happening on the screen. Even this, to be honest, whatever you're watching over here, even it's of the same nature. Bunch of pictures running at a rate which makes you feel things are happening in front of you. So by changing the perspective, by giving it reference, we can make object feel like it's moving, it's stationary, it can be anything. It depends on the point of view. Now, when motion itself is relative, right? Every aspect of that is also relative. So we're looking at something called as relative velocity. Because velocity is nothing but rate of displacement with time and all of that. If displacement itself is a perspective thing, so why not velocity? It can be, right? So what it means is, I'll give you guys a simple example. Actually, let me do it on the screen. If we happen to, be sitting in a car or say train, we are sitting in a train. So two people sitting over here, head can be bigger. There's a kid sitting over here. So for a person who is standing out, these people are, what is happening? Oh, not a, or walking. So these people are in the car or in the train, moving with the same speed as that of the train, right? For a person who is standing over here, so that would be the speed. Kid is moving at a rate of S train. So that can be 60 kilometer per hour, so on and so forth. It can be anything. Now, this person, what can he or she consider this kid to be? Is the kid running away with that speed? It's dangerous, right? Letting a small kid move away at say 60 kilometers per hour on his or her own. It's not practical. But even then, the person over here feels safe. Why is that? Because the kid is at rest. Do you guys agree with this person's perspective? Is someone wrong over here? If so, who is wrong? Is anyone wrong over here? Yes or no? Answer is no. Both are right. But why is that both are right? Because of relative velocity. If this kid is moving and the kid is moving at a velocity which is equal to that of the train, this person also is moving at a speed which is equal to that of the train. Because they have the same speed, it will cancel out and the person will look at the kid that as if the kid is at rest. They can have that comfort. Say this is the mother or the father, the kid is sitting in front of them. For this kid who is say the grandfather or grandmother or uncle or aunt, The kid is going away, So he or she will come back in the next summer holidays or winter holidays. Right? Does it make sense? So this very picture is this entire video. That's it. Not this video, this section of the video. And relative velocity is one of the toughest topics that people, the kids find that relative velocity is tough. But if you understand this, if this is commonsensical, then relative velocity is easy. Right? So it's just a matter of simple subtraction and addition. Depending on case by case, not a big deal. So you need to use common sense. I'm sure every one of you have that common sense. It's just a matter of taking a pause, thinking over it, and you have the answer. Okay, yes, not that difficult. So the basic idea of relative velocity is that how fast is something going compared to another object, generally moving, not just the ground. So we have two things that are moving, right? So with respect to each other, how is the other person's motion? So one more example is if you guys are sitting in a car, okay, that this two also we have something like this, right? So this particular vehicle looks like as if it's moving very fast. But if you are sitting from in the red car, remember, this is the actual, if you're sitting on the tree, this is how it will look like. But for a person who's sitting in the red car, this would be the perspective. The blue car looks to be very slow, is it not? Again, it's the perspective. And all of these values are right, guys. All of these values are calculated and then animated. So for a person who's sitting in the red car, right, the blue car and the tree and everything looks to be in that motion. So this might be so. But if a person is sitting actually in the red car, the perspective will be different. That you guys would have felt. See, I'll give you guys one more practical example. If you're sitting in a bus or a train or, okay, we'll go with the bus. That is a better example. Your school bus or, your local bus. If you're sitting in that, or if you're sitting in your car, and if it's moving at say 60 kilometer per hour, if there is another car or something, oh yeah, I forgot, you guys are in 11th grade, I can talk to you guys. I need to keep switching between 6th and 11th, so sometime I kind of go with very simple examples because I'm still in that mood of teaching a 6th grader. So you guys get to see this another car, say moving at say 60 or 70 kilometer per hour. They look to be slow. You can look at them, the details. If this car is also traveling at 60 kilometer per hour, whosoever is driving, you will be able to see that person very clearly, right? I see her clearly. So this would be the perspective, while the person standing over here, I think I know her. The person will be guessing. Do you guys agree? So it won't be a sure thing. But for this person, for you guys, it will be a sure thing. Is it not? Why? Because the relative velocity between the bus and the car is zero. It's like they're stationary. If you have seen videos wherein people do stunt, right, on a moving vehicles, not just one vehicle. If you've seen the movie Speed, if I remember right, so there is a scene wherein they have to deboard from a bus onto some, okay, that's a bad bus, onto some, I don't know, truck, I guess, not truck exactly, but I think it's a truck. They keep something over here. They maintain the speed and the people pass over. You guys can watch this. I'm sure it will be available on the web, right? The movie Speed. So the velocity of this vehicle and this vehicle is matched so that the people can get off board. Okay, so that's one more thing. Example, your car and a tree and another car. Take a second and imagine how it might look. So actual situation is, I actually showed it to you guys. This is actual situation. But from the perspective of a person sitting in the red car, things would be so. Okay. So things will look like this. How things looks to people sitting in your car. Then we have the representation. So we have, see, 1 minute. This is it. So this is how you generally represent velocity of the car is v1, velocity of the second car is v2, and that of the tree is say vt, which is 0. So this is how you generally represent. But when it comes to with respect to the first car, it will change in this manner. So velocity of car 2 with respect to car 1, velocity of tree with respect to 1. So this is important. So I'll write it and you guys have to copy. Copying this, and this is a movie. Speed. Okay. So it's a bit old, but it was a hit when it was released, and it is so actually. People do like it. Okay, so now we are talking about representation. So this is with respect to ground. So this is a case of ground. So you have one vehicle, you have another vehicle, and you have the tree. So if this is V1, this is V2, and this is Vt, which is 0. Okay, so this is a lot more than this. If this is a scenario, now with respect to case from point of view of R1, things would be, see, this is stationary. Because you're sitting in that car, you're stationary. The tree will be moving in this direction with the velocity of Vt1. How do you find the value of that? That we'll understand. Right, the tree is also moving. We could see that from this video. No, this video. Right, a tree is also moving. That you guys get to see when you sit in any vehicle or even if you walk actually. If you consider yourself as stationary, everything else around you is moving. And this will have a lot more velocity, and this would be V21. This is the representation. This you guys need to know. This is velocity of vehicle 2 with respect to vehicle 1. Velocity of vehicle 2 with respect to vehicle 1. Okay, so there are many ways to represent this. It depends on the book and the author and all of that. So here we are going with this representation. Okay, just a representation, guys. It's just a symbol. Okay, and right. So V21 and VT1. Done. And I think anything else? That's it. So velocity of object 2 with respect to object 1, so on and so forth. You guys need to write all of this. So post this write up. You can draw. It will help. And then regarding the representation,